As we have already seen, Hibernate more or less works okay when we have one-to-one relation, and this relation is under the hood of inheritance between entities during using Hibernate. But also, one-to-one relationship can be established on Hibernate level by using annotation one-to-one. And Hibernate in this case offers us supporting referential integrity for one-to-one relationship between these two entities by using cascade operations. The following cascade operations are available for this type of relationships. Persist. It propagates the persist operation from a parent to a child entity. Merge. The same, propagates the merge operation from a parent to a child entity. Remove. It's a type cascade operation from GPA and analog in Hibernate it called delete. I think here no explanation is required. And also we have a cascade operation refresh. A child entity also gets reloaded from the database whenever the parent entity is refreshed. About this refresh, we already seen how Hibernate refresh to process refreshing of entity when when it's needed. For example, when the entity is untouched, as from previous, let's say from previous slide, then additional select query is being to send to database. Yes, this also this refresh cascade operation has nothing common with referential integrity. And what I want to say here, with one-to-one relationship, which is implemented on Hibernate on our application with annotation one-to-one, we can use any of these operations without any problem. For this semantic, it's okay. But later I will show you that for some other type of relationships, we should first think and then use these cascade operations. Now let me say several words about one-to-many relation and the data consistency. In this situation, Hibernate also offers us supporting the referential integrity for one-to-many relationship between two entities by using cascade operations. The set of cascade operations is the same as for other relationships in Hibernate, and we already have seen the list of operations and discussed it for one-to-one. Here, for one-to-many relationship, usually we use one-to-many annotation. Another interesting example for pursue referential integrity is an orphan removal feature. Let us imagine that there is a parent entity and which has a set of or list of corresponded child entities, and let's say that we are going to call entity orphaned when the entity is not longer attached to its parent. Then this orphan removal feature is used for deleting orphaned entities from the database. Let us also take a look at a real program code example. Before it, I would like to introduce you the simple database scheme which we would use in this program code example. In this database scheme, there are two tables, one for users and one for posts. And there is one-to-many relationships between users and posts. And it means that users can have 0, 1 or more posts in some system, let's say. And the attributes set of these two tables we can observe here on this diagram. Now let us jump to IntelliJ and take a look on the next test case. For our next test case, I have introduced two entities. One user entity for table users, and another entity which reflects table posts with name, and the name of this entity is a post. Here we can see that there is one-to-many relationship between user and post entity, and this relationship is reflected here. Here I have written that I would like to support only persist cascade operation, and I would like to support orphan removal true. What else? Here, nothing more. I have two repository, one user repository, just its usual GP repository, and one post repository. What I have here, it's important from my previous video, I have, let's say, some leftover, and I'm going to use it here. It's a flyaway script, which is inserted data to the users table and post table. And that's why in my test case, I already have data. Let me overview what I have in my test case. In my test case, I have two transactions in one method. For these purposes, I am using transaction template. And in first transaction, I am retrieving all users from database. From this list, which is the result of retrieving, I am taking first user. From this first user, I am getting all posts of this user, which is connected to this user. I'm memorizing in atomic variable the initial original size of this post collection. Then I'm taking first post from this collection, and I'm removing this first post of first user from collection of post of first user. And also I am memorizing first user and first post of first user in some atomic variables. And it's, let's say, the last operations in my transactions. Here I needs no call of safe methods of repository because dirty checking of Hibernate is in action. And what I am going to, let's say, to which result I'm going to have here of this transaction. I would like to have here that Hibernate would generate for me a delete command of deleting from database a post which I'm removing from a collection on Java on Java level, let's say. Several words regarding dirty checking of Hibernate. It's a built-in mechanism to check which entities were changed during a session of Hibernate, and at the end of a session of transaction, Hibernate would generate let's say safe SQL commands for these changed entities. And regarding atomic references, I am using it to avoid fulfillment of requirement for variable to be effectively final in Lambda expression. For, let's say, for productive code, I consider this approach to use atomic references to avoid this effectively final requirements as a very bad habit. But for test test code, I think it's okay. And the second transaction, it's what I'm doing here. I'm retrieving a first user from a database in another transaction, And I would like to check that the collection of posts of this user, the size of this collection, is equal to previous size minus 1, because this one post from this collection should be deleted on database level, and that's why shouldn't be retrieved. And I also, let's say, would like to make double check, and I would like to check that this removed post on collection level in first transaction is also removed on database level. And it was, let's say, description for these two assertions. And if I run this test case, I expect that it would be successfully executed without any errors on this assertion, especially in this assertion. Let's run it and check. Yeah, and it's executed successfully. Now, let us take a look on many-to-many relation and the data consistency. Here, Hibernate also offers us supporting the referential integrity for the many-to-many relationship between two entities by using cascade operations. But for such semantic, a child item can have more than one parent. To take more details, let us imagine the following situation. A parent A has two children, C1 and C2. The child C2 has two parents, parent A and parent B. Then, when we delete the parent A, we cannot delete the child C2 in the cascade mode. The same situation could occur for the inserting or updating, I mean the links. That is why we need to use the cascading operations for many-to-many carefully. In general, it's not recommended at all. That's why each time when we come across with many-to-many relationships in our application with using Hibernate, each time I would like to highlight. First, we need to think about all scenarios regarding manipulation of our data. And when we have a clear picture, then we can carefully use cascading operations. But in general, if we would avoid it, it would be the best choice. It was all from my side regarding maintaining referential integrity in Hibernate. I would like to say thank you for your attention, and I hope that this video would help you in your daily work. If you would like, you can follow me on GitHub. And once again, thanks a lot and have a nice day.